Okay, so this is part 2 of the answer to question 1 on exam B for mixed programming. Okay, so hopefully this will be a quick video, like 5 minutes, like, I don't know, maybe 10, but yeah, I just didn't want to put it into one video because, like, the first video, I was like, okay, so like, assuming that, like, I don't know, you did this yourself or watched the other video, so, yeah, I mean, like, this is what we have. Okay, the question says, so you won this program that we just went through, and the question says, how many no char star objects are leaked at the end of the program? Write the number of objects, not the number of bytes. And write 0 for no leak. So, remember what happened in our OA tilde function? We had this thing, right? And so, and then the stack rolled up, and these pointers, these smart pointers were like whatever destroyed, but these things were not destroyed because they still had greater than 0 references. Okay, so that left us with this diagram, which I'm actually going to redraw right now. So we had c equals 0, and remember it wasn't really c plus 0, it was pointing to the a or whatever, but I just did it like that. So we had this, right? And this was pointing to c plus 1. And this was pointing to c plus 2, and this was pointing to c plus 3, and really there was another thing, the heat tubular 1 or whatever, but like, you can just look and be like, oh, well, the reference count of this is 1 because it, like, only one other thing is pointing to that. I mean, like, yeah, I'm just not going to draw it because, yeah, I don't want to, like, have too many arrows. So, okay, we had this, and then we had, and we had our vector, which had, and then this is on the heat, remember? So we had a vector that's back here. And then on the heat, we had this, so the vector, like this was the first step of the vector, this was the second one, and this was head, and this was tail, and head was pointing here, and tail was pointing there. Fine. Was pointing there. Okay, and also this pointer was pointing to the same place that head was pointing, which was there. Okay, so this is what our diagram looks like. Now, the function, and we also have that other thing at the end that we declared, like an extra node. That's not going to do anything. It's not related to this. Like, it's just like a smart pointer pointing to some node, like somewhere in the heap, but it doesn't matter because like this is the reference count of 1, right? So when the stack rolls up, this can get destroyed, right? And so it's going to go to 0. And so like, because the deconstructor is going to call, and this is 0, so this thing gets deleted and like everything's fine. So that's not going to do anything. Okay, so yeah, so we have this. And now the question says, like, okay, so how many no char star objects will leak? Okay, so when the stack rolls up, what's going to happen? So you have head and tail in your vector, and your vector is just a stack variable, and when the stack goes up, like everything in the vector is going to get deleted. So like that's just the way that like vectors like work. It's like, I mean, it makes sense because you want to delete everything that's like a vector. So your head and your tail are going to go away, right? Which is going to mean that this is, so they're not going to be pointing to here, right? Because the deconstructor are called. And this is here. Okay. But it's really important because head was pointing to this, right? And normally you'd say, yeah, fine, head is pointing to this. So when this, like, when the stack goes up, this thing, like, goes away, and the reference count goes to 0, and this gets deleted. But that's not the case here, because we still have this is pointing to this, and, like, things are still pointing to all these. Right? So, like, these things aren't going to get deleted like they should. Okay, so when the stack goes up, you're still going to have this thing, which is, like, in the heap, which is, like, a leak, which is bad. So you're going to have 4 no char star objects that are leaked. And now, the next question, so how many bytes are leaked? So this is why you should draw the things, because, so you need to draw the reference count of each of these, right? So, because really, like, a smart pointer has two things. Like, it has the whatever it's pointing to, and then it also has the reference count of the heap. The reference count of all of these is 1, right? Because they're only pointing to one object. So, okay, then, what is the size of a smart pointer? So a smart pointer, if you look at the, like, whatever template thing, it says that a smart pointer has two elements. It has t, no, wait, hold on. A smart pointer has two elements. It has t, which is a pointer, and then it has, so yeah, it has t, so t, which is a pointer, and then int, which is a pointer. So like, yeah, it has that and that. Okay. Okay. So a pointer is 8 bytes, right? Yeah, a pointer is 8 bytes, which means that this smart pointer takes up 16 bytes. Okay, so this is 16 bytes right here. And then, so that takes care, so a node has the data, right? And then it also has the smart pointer. So we're trying to figure out the size of this node, okay? So each smart pointer in the node is 16 bytes. And then what's the size of the data? Well, the data is a char star, like we talked about before, so this is 8 bytes. Okay, so we have 16 plus 8. That gives us 24. Okay. So you say, fine, there are 24 bytes in each node. But the smart pointer actually has an extra 4 bytes because it has this. There's an extra 4 bytes because this is in the heap and this is an integer, like, or int. So this is an extra 4 bytes, right? So we really need to add an extra 4 to each of these, get 28. So then we have 4 things in 28 bytes. And so 28 times 4 is 112. So 112 bytes. Okay, so what would happen if we changed, so like, okay, back up a little bit, and before the program goes out of scope, so head is still there, and tail is still there, and head is pointing to this, and tail is pointing to this. Okay, so if we say v0, so this, so basically we're going to say, okay, get rid of head, and get rid of what it's pointing to, and replace this with like null speed. So this is just like a thing, it's like pointing to like 0, whatever, from before. It was declared in the stack earlier. Okay, so this isn't going to change anything because now when the stack goes up, you're still going to have, everything is still going to have a pointer to it. This is going to have at least 1, this is going to have 1, this is going to have 1, this is going to have 1. Even when tail gets destroyed, it's still going to have 1. So this isn't going to change anything. It's going to be the exact same thing we just talked about. And so it's going to be 4 now. Okay, so now this is literally the same problem. Now we're saying, okay, like you have head again, right? But you, you have head again, but tail is a null, tail now becomes a null pointer. So okay, rather than tail, you have this null pointer, so this doesn't exist. But it's the same thing, right? This still has 1. That still, this one still has 1 from that. So it doesn't matter, it's still 4, it's the same exact thing. Okay, now we're saying, so head and tail exist, right? These exist, okay? But we're saying that v0 dot max. So this, we are changing that to a null like pointer. So to the null smart pointer thing. So this is going to become basically just a pointer to 0, and we're going to get rid of this and rid of this. And this is important because look what happens now. So when the stack goes up, and so head gets deleted, okay. Now head gets deleted, and tail gets deleted, okay. But when we, like the instant that we change this to a null pointer, this thing doesn't have anything pointing to it, so the reference count is 0, right? So when we change that and like we call the like whatever equals operator, this whole thing got destroyed. Okay, now this thing's gone, it's out of the heap. So we don't have reference count here anymore, so that's gone, right? Okay, so this is gone, so we don't have, so we still do actually have a reference count to this. We still do, because tail is pointing to this, yeah, so because tail is pointing to that, it's pointing to that. Okay, now the stack goes up, right? So tail gets destroyed, because it was in V, and V like deletes everything inside of it. So tail goes up and gets destroyed, which means that there's nothing pointing to this. So this gets destroyed. Okay, so this gets destroyed, and then that gets destroyed, and so whatever this like reference goes away. So the only reference left of this is head, but head is also getting destroyed. So this goes away too. So now you have 0. So it's 0. And it's literally the same thing. I'm not going to go through the other ones. Like v1.x, the same thing is going to happen, except instead of this one, instead of messing with this one, we're going to be messing with this one. So it's going to be pointing to like 0 or whatever. Same thing's going to happen. Like, okay, this point to 0. So now when the head goes away, it's going to be nothing left pointing to this, which is going to cause this and that, like chain reaction, whatever. So those are all gone, and it's going to be 0 again. So that's 0, and then v0 next, so that's just like changing this one point to 0, same thing's gonna happen. You can go through it just like we did there. And then v0.next is pointing to an extra node. That's literally the same problem as 1.22. It's just like, it doesn't make a difference. Like whether it's pointing to 0 or it's pointing to something else, doesn't matter. It's gonna, an extra node is just a stack variable, so it's gonna get destroyed when the stack goes up, and the same thing's gonna happen. Yeah. So they're like that's 0, and yeah. So like yeah. And that is the answer to the second part of the problem.